Hello everyone. Today we're going to be talking about the image recognition with Teachable Machine and ML5.js. We are mainly going to cover the example with Teachable Machine by Google, but we're going to mention other libraries as well, like TensorFlow and ML5. So let's start. I would like to start with what is image recognition. So a lot of you probably heard about it, but let's see how it works. So basically, image recognition is when you have an image that is being processed by the computer, and the computer is able to label this image as, if we give it a picture of a cat, it will understand that it's actually a cat. And how it usually works is that the algorithm that we have will get the picture, will analyze all of its pixels, will turn it into numbers, will put it through some layers, and based on the calculations, we'll understand whether that's a picture of a cat or a dog or something like this. But for this, we'll need to train our model first to actually understand what a cat looks like. So it's basically like a little child that you have to explain, where here's the picture of a cat. This is what you call a cat. And the more picture we give it, the better it'll work. So let's see. So image recognition refers to technologies that identify places, logos, people, objects, buildings, and several other variables in digital images. It may be very easy for humans like you and me to recognize different images, such as images of animals. We can easily recognize the image of a cat and differentiate it from the image of a horse. But it may not be so simple for a computer, of course. A digital image is an image composed of picture elements, also known as pixels, each with finite discrete quantities of numeric representations of its intensity or gray level. So the computer sees an image as numeral values of these pixels. And in order to recognize a certain image, it has to recognize the patterns and regularities in this numerical data. So how does it work, basically? So if you take a look into example, typically the task of image recognition involves a certain of neural network that processes the individual pixels of an image. These neural networks are fed with as many pre-labeled images as we can in order to teach them how to recognize similar images. So in basic words, as I made the example earlier, if we have a lot of pictures of a cat, then the program will basically understand after some time of feeding this program with those pictures that this is a cat. But every single time we feed this program with our pictures, we need to label them as this picture is a cat. So it'll find similarities in those pictures. So as was mentioned before, what we see as human on this picture will probably be seeing a dog's eye. But what a computer will see after turning in the data into numerical data, it will basically be just finding the patterns of numbers. And based on those numbers, it'll be able to later tell that those numbers of pixels are usually the eye of a dog. So what is the easy way to get started? So as was mentioned before, today we're going to be talking about Teachable Machine. So Teachable Machine is a service by Google, which is available to be used directly from your browser. So you can just go to their website and you can get started with your neural network teachings. So what is a Teachable Machine? Teachable Machine is a web-based tool that makes creating machine learning models fast, easy, and accessible to everyone. Teachable Machine is flexible. It uses files or capture example live. It's respectful of way you work. You can even choose to use it entirely on device without any webcam or microphone data leaving your computer. Right now, it works with images, sounds, and poses. So you can not only train your neural network models to recognize images, it can also recognize some certain sounds and poses. Basically, the idea behind it is basically the same, but in our example, we'll be looking into images. So where do we start? So the first thing that you want to do is basically go to their website. and start gathering classes information, which is labels. So for example, let's say we want to create an app that'll be able to recognize the pictures of the street without a car and just a picture of a car. So you'll create the first class that'll be named something like streets without cars, and you will find the images on the internet or take them yourself and upload it to the website. And we'll label all of those images as a folder into images of street without cars. The second class you create will be images of a car, and then you just find some pictures or take them yourself and upload them to the second folder you'll have. And basically that'll be the first step of your gathering information for the neural network that we're about to train. So the second step will be just clicking on the train model button. After this, what the program itself, the teachable machine, will do is that after we labeled all of the images we had, it will actually start training the neural network that'll give us the file that we can later export and use in our project. So this is basically as easy as 3 steps. You basically gather the information, give it the images, label them, train the model directly on the website, no need for coding on this point, and then you can just easily export your model to a file. So what are you gonna do later with those files that Teachable Machine will give you is that we're gonna experiment with them with just different libraries. So right now, there are multiple libraries that can help you work with your models. One of the most popular one is the TensorFlow.js. And there is another library that is on top of TensorFlow.js, which is the ML5. So ML5 is basically took all of the things that TensorFlow.js has and made it very simple to work for front-end developers directly in the browser. So with the ML5, ML5 is the open source friendly high-level interface to TensorFlow.js, a library for handling GPU accelerated mathematical operations and memory management for machine learning algorithms. So ML5 provides immediate access in the browser to pre-trained models for detecting human poses, generating text, styling an image with another, composing music, speech detection, and common English language word relationship, and much more. So you can actually go to their website, which is the learn.ml5gs.org, and you can study their documentation. What I like about it is that they have a lot of very basic examples of how you can use already pre-trained models. So one of the most popular pre-trained model right there is called MobileNet. It basically has thousands of images that it already knows. So it's open source model, which was trained by a lot of people. Basically, if you don't have the time to train your model to recognize most of the images and you want to use something very broad that will recognize as many pictures as you want and you don't have time to train the model, you can basically just connect someone else's model or buy a model from someone else if there's such business. So as an example of MobileNet, it's totally free. So there's an example on their website on ML5.js is where you just connect to MobileNet model and you can upload any picture. So in their example, they put a picture of a robin, which is the bird, and you can see that it gave us 2 things. So it gave us the label. So it gave us 3 different options for the label. It gave us the robin, American robin, turdus, migratus, and it gave us the confidence level. So the confidence level for those kind of libraries is usually from 0 to 1 point decimals. So right now it's confident at 92% basically that it is the robin bird. So it doesn't just give us the label, it also gives us the confidence levels of how confident it is in those exact labels that it gave us. So ML5 is pretty cool. You should check it out. In our particular example, we'll be using the lower way of connecting it with just TensorFlow directly. So what I would like to do is to take example into our code. I've created a basic project, which is the app that will actually have all of those pictures of the streets without the cars. and some random images plus the image of a car. And with our example, it'll actually be able to recognize all of the images that has a street without a car and all of the images of a car. I was actually inspired by reCAPTCHA. When you go to some website, it'll actually tell you, hey, if you're not a robot, then you have to choose all of the images of a street and things like that, or all of the images that contain a car. So I thought, what if we develop an app that will actually be able to bypass a CAPTCHA? Isn't that kind of funny that a robot will be able to bypass I'm not a robot test? Of course, I didn't create the real extension that will be actually going to reCAPTCHA and selecting all the images. But what I did is I created a basic HTML template that will actually generate the images and put them in the random order every single time we refresh the page. And we'll have our app run. And once it runs, it'll actually pre-select all of the images that has a street. So basically, if you take the same code and put it into, let's say, Chrome extension or something like this, you can potentially bypass, I don't know, reCAPTCHA by Google. So let's see. So I would like to open my Visual Studio Code and let's take a look into our code. So let's see what we have here. So basically what I did is I've created a basic project. So the first thing we would like to pay attention to is the folder that is called My Model. So My Model is basically a folder that was generated by Teachable machine by Google that we exported. So what we want to do with our folder, it basically has this file of our model that is neural network readable text, I guess, which you later feed into the library. And based on this library, this model.json and our weights will actually be able to recognize what we want from it. What I also did is created a test folder and I uploaded some random pictures from the internet of 6 images. So let's see, let's take a quick look on our images. So the first is just a street without any cars. The second is a street that has some cars on it. The third one is also a street but 0 cars. Fourth is just the beach. No cars or no street here either. So fifth would be just some house interior. And the sixth image would be also a street, but you can see just different style of the images. Like this is horizontal, this is vertical, or another way around. And so how does it work? Where do we start? So the first thing, we would like to just basically create our HTML file, what I already did. And I also added some styling to it. So I just added some CSS to make it look better. So if we actually start taking a look into our code, you can see that what I did is I basically just created a div that will have our CAPTCHA simulation, because this is not, again, as I said, this is not a real CAPTCHA. We're not bypassing a real CAPTCHA. We're just bypassing a simulation of a CAPTCHA. So I've created a div with ID CAPTCHA. And basically this div will have our images as just HTML text. So basically this div will have something like image source, test, and maybe ID of that'll just be equal to the file name. So something like this. And this is what our div will be containing, just the list of those 6 pictures. But I'm just generating those images myself because every single time, as I mentioned, I don't want it to be this way. I want to, every single time we refresh the page, it to change the order. So you don't think that our app is actually dumb. It just knows that every second or every 4th picture is the picture of the street. It will have no clue based on the order. And the only information we have about our images is just their names, which is the numerical number of 2nd or 3rd or something like this. The same with our IDs. They're just basically plain test and also their ID of the image, but nothing that is labeling them at this point. So what you can see here, I did connect 2 libraries to my code to get started, which is the TensorFlow library, which is here. And I also connected the second library, which is the library from Teachable Machine, which is the Teachable Machine image, the mean.js, which is basically to work with our image classification. So basically, just those two lines of code will basically allow me to connect to my model folder and will allow me to use my model in my front-end code, which is pretty cool. So let's take a look into JavaScript that we did here. So first we want to have is the folder for our model. You can see that our URL is just this folder. Then we'll also have a few variables here, which is the model and max predictions. So max predictions will equal to the amount of labeled images that we can have. So in my example of my model, I only created 2 labels. It only knows 2 types of images. I didn't even fit it with enough data. I think I fed it with like 5 images of every example. So it's not like a very smart model, but even those images will be enough to recognize some certain patterns. So max predictions in my case will equal to 2. It'll either be cars or street without cars. So we basically have the init function, which will be called as the event on our button when we press start. And what it will be doing is getting our model URL and our metadata URL, which is, again, as I mentioned, just the data from my model folder. So it'll load the model and metadata. It'll random to image load from files in the API to support files from a file picker or files from your local hard drive. This is a note from Google. Note that the pose library adds the TM images object to your window. Okay, so we're now working with the pose model. Right now, we're just working with the image recognition model. So how it works, we basically have our model and it will evade image load model URL. So this is how we basically connect our model. So we just call this function and passing our model JSON and model metadata to it. And max predictions will it'll count total classes, or I can just do manually too, because I already know the number, but it'll be better if it counts itself. And I'll be calling the predictions, which is I have 6 images, so I did it manually. I will predict 6 times 6 images. Okay, so let's take a look into example of our predict function. So how does it work? So the predict function will actually be getting our images. So before going in depth, so the predict function will go into how we print images on the page. So basically have just 2 basic functions. The first function is just to have our arrays sorted randomly. And this is our array of just 6 images. Because in the end, as I said, we want something like this to be popping into our div. So we have the array of just 6 images. Every image will have its own unique name, which is either 1, 2, 3, 4, 5, or 6. We'll be shuffling the array. So it'll give us back something like 2, 3, 1, and just our values in the random order. And then we have our HTML variable. And then we're basically just collecting making all of the HTML as a string just to print it later on the page. So we'll just insert it manually by ID in our HTML will equal to the 6 lines of HTML that will have unique ID and unique path to the images. So this is how we print images on our page. Very basic, very plain. I like it. And let's go back into our predict function that is being called here. And as you can see, every single time we call the predict function, we actually pass in the image name to it. Because every single time we create the image, it has the unique ID, which is the test, and either 1, 2, 3, 4, 5, or 6. So here it is. Very basic, just 20 lines of code. Here it is. So our predict function is taking the ID, and it's actually looking for the element on DOM of our image. So it'll be looking the element with test and our number. So if we pass number 2, it'll be looking for test number 2, very basic. You can see that it'll predict based on this constant. So our const prediction will actually call for the function from our model, which is the predict. And what we do pass here is just our DOM image. After we pass our DOM image to their file, we'll be calling our loop that'll just be looking for all of the predictions. So it'll basically be giving me 2 values every single time. So if the prediction is cars or if the prediction is streets. So because I want to label both of them. So if it's let's say the image of a street, it'll give me something like the car is equal to 0 or some certain percentage of how confident that it is a car, and it'll give me this some certain percentage of how confident it is that it is a street. So how does it work? I have this class predictions, which is basically a string where I collect the prediction name and prediction probability for every single picture here. And then I just console log. So here how it works. If prediction class name for this image will equal to our label, which as I mentioned, we have only 2 labels. The label name is basically what we named it when we were creating it in the Teachable machine. So I created 2 labels. The first one is street and the second one is cars. So if prediction class name is a street, then what I basically want to do is check for probability. So as I said, that 1.00 will be basically meaning that it's 100% sure based on our model that it is a picture of a street. So in some cases, it can be sure by 80% or 70%. So I can basically say not strict equals, but say you can say that it is a street as long as you're confident that it's 0.9% that it is a street. So if as long as it's 90% and up, that is a street. What I want to do in my example is just take only 100% prediction. So if it thinks, but it's 100% a street, then it will work. Then we want to keep it here. And what we want to do there is just to add a basic styling to it, which is editing it with our CSS, which is just a border of 7 pixels and light green. So this is our code here. And I'm not going to be going in depth of my styling, but this is just to make it look better. So let's save our code and let's see how it actually looks like on our website. So here we have this website that has all of those 6 images of, as I mentioned, the first image is the ocean or the beach. The second image, how I would label it as a human. The second image will be the street, then some interior, then a street, then a street with cars, and then empty street as well. So as you can see, every single time we refresh the page, it'll actually give me a new order of images. So let's just choose what we like. Let's say we decided to stop here, and let's call for our start function and see how it works. So as you can see, our program went through all of the images that we have here and highlighted all of the images that it thinks that it is a street without any cars. So you can see it worked pretty well. And if we do check our console, so if we go to console, you can see that it gave us, for every single image, it gave us the values of how confident it is. So basically, in some cases, it was sure that the car is only 94%. And in some cases, it was thinking that the street is only 85%. But as we said, we basically just want to look for 1.00 values. So, but it works pretty well. So if we refresh the page and click on the start button again, you can see that we basically just created an app that will probably be able to bypass every single captcha that is asking us for certain images. So especially if we use something like, not, let's say we don't want to use our model, let's say I mean, Google Capture usually has just images of the street, cars, things like this, or stop signs. So basically, I would say you can pre-train a model to work with reCAPTCHA specifically, or you can use something like what would that be? MobileNet, which is will have most of the images and will be actually taking. Let's say you have this universal captcha that will be giving you new values every single time. Let's say like find the pictures of flowers, and if we take the prompt, which is the flowers, and give it to MobileNet, it will probably be able to predict it. We'll just need to be able to grab all of the HTML elements of the images from our reCAPTCHA, put it onto our program, and then label them and simulate clicks or something like this. So you can see that it works every single time if we refresh the page, but let's say we want to change it to our second class. Just to try it out, what we have is the images of cars. So if we go and change it here manually, just the images of cars, we want to save it, we want to refresh the page. Let's say we want to change the order a few times. I think that's enough. So we only have one picture that really has cars, is this one. So let's click start. And you can see that it worked pretty well. And if you look into console logs, it'll still be the same predictions for all the other images with the same levels of confidence. But the only one image that had car as one, which is the image with ID 2, I guess, because basically in my console, I'm printing the numbers as their IDs. So if the image had the, so let's see. Yeah, so our actually image is second. So first two lines is the first ID, second two lines is our ID, which is the image of the car. So it gave us the prediction that street 0 and cars 1%. And yeah, so it works pretty well. So you can pre-train every single model you have to work in the way you would expect it to work. So we can, as I said, play around with it, add different styles to it. Yeah, that is pretty cool. And if you look more into examples of image recognition and or go to the ML5.js, you can also do a lot of fun projects with it. For example, you can use the camera in real time to attach some layers of masks. So for example, if you use a model like PoseNet, you can basically create an app, especially with ML5.js on top of it. You can basically create an app that'll be able to attach some sunglasses, that'll be pixel sunglasses on your face while you move around the screen. I think this is how layers on social networks like Instagram would work if you use some masks and it actually puts some realistic masks on top of your face. It actually knows where your eyes are at and things like this. So most of those kind of libraries are actually working with DOM elements. So if you have a Canva or any video source where you're presenting your camera, then it can be easily be changed to add masks or layers. There's a cool library, p5.js, that is allowing you to play with canvas. So if you look into most of the examples of ML5 website documentation, you will see that most of their examples are using the P5 just to print those canvas and to put some cool layers on top of it. With Teachable Machine, as I said, this is just was the example of image classification, but there are way more examples. So imagine how many cool apps you can build with this. You can basically, if we're talking about the robot development, of course, right now we're talking about the front-end development, but if you look beyond this, then you would understand that it can be used on factories. Let's say you can set up this camera that'll be basically able to predict whether or not to put something like, let's say there's this factory of water bottles, and let's say some water bottles already have lids in it, and let's say some don't. Some of them doesn't have, some of them will not have it. So you just have this camera that'll be able to just basically recognize a picture of a bottle without a lid and a picture of the bottle with a lid, since you will have only two classes and it'll only be two types of source income. So just this bottles, it'll work pretty well. I would say it'll work perfectly. So that way you can transfer factories, and there's so much more apps you can be doing with it. For example, you can say, hey, if you want to log into the app, you gotta take a picture of or you can create an app that will be giving you, I don't know, like quizzes. Hey, today you have to take a picture of a butterfly. And if a user is able to take a picture of a butterfly, then you reward them or something like this. There's so many ideas that you can be using with this kind of neural networks. On this topic, though, there are, as I mentioned, there's a PostNet, and right now Google allowing you to also train um, via sounds. So you can just go to Teachable Machine with google.com, and it'll allow you to actually record some sounds, and it will be also able to recognize some certain sounds. There is also similar ways to find some objects, but here it is. You should not be mixing the image recognition with object detection, because this are completely two different things. Even though in my head it'll work as, here's this image, and we just need to find this object, but that'll actually be a different type of models. So what image recognition is able to do is just able to have the labels for the image itself, but it's not looking for the objects on the picture specifically. So if you want to develop an app that'll be able to find certain objects on the pictures, then you'll not be using image recognition, but you'll be using something else. So image recognition is perfect for labeling the images, but not finding the objects on those images. For that, you would use the object model or something like this. I wouldn't be too sure about the name, but this is just to keep in mind that those are two different things. As a front-end developer, you would not need to know that much of how those neural network works, how does TensorFlow actually is able to put all of those numerical data from pixels, put it through the layers of learning and give it different weights. But this is just how it works. It basically takes the picture, takes the pixels, put it into numerical values, put it through their layers, and here it is. We have these predictions with the confidence levels and different weights. So yeah, if we go back to our code, you can see that a lot of this code could be done even in smaller lines. And yeah, we can clickbait name this, that how to create a neural network or how to bypass reCAPTCHA in just 100 lines of code. And if we go to our presentation, you can see that this is the app we developed in just, as I mentioned, under the 100 lines of code. And this should be basically enough for you to get started with image recognition. And it is always fun and cool to play with it. And I would encourage you to come up with your own idea for the app that you want to develop with this. As I gave you some of my ideas were to have this, let's say, app that will stimulate users to find pictures of something, or factories could be using it for labeling things, or you can be also using the face detection, which is also a different technique. Probably if you want to have certain face, let's say you want to work something like Face ID that Apple has, then this would probably not work as well, because if you look into the ML5, they also have similar ways for facial recognition. If you actually go to the ML5.js website, you can find that they're actually going beyond the Teachable machine, because they also work with models for text. Yeah, so you can have text predictions, or you can have it to help you write the text and things like this. One thing also that I want to mention when working with Teachable machine is that when you transform your images on the DOM with some CSS properties. So for example, you have this image and you want to change it width, or you want to artificially expand the height. So as you can see here in this example, I don't have the heights of the images to be in the same way on the same rows. Every single image of here has its own proportions. and why it is important to keep the proportions of this image, because if we do so, if we do update the proportions, which I found now to be pretty interesting. And yeah, so if we update our code, so right now our code is looking for cars. So let's put it back to look for streets. Or yeah, cars could actually be a better example, to be honest. Sorry. So let's go back and set it to be 100% height, and let's say we want the object fit to be covered. So as you would originally think that it should not affect our neural model to understand any of those images, but what you actually gonna find out that it's not taking the source of the image. It actually takes the DOM element that we have on the page. And so if you were training your models to be looking for those kind of images, and now you have the street that is actually kind of disturbed by the HTML element, the neural network might not even understand it on the page. So when working with this, you have to be careful when you transform your images like this. So for example, if we transform our images, now when I start my code, it actually does not find any images here. So let's take a look into ID. So this is our second ID. And here you can see that the car prediction now 0.98%. So basically we just transformed our image slightly, but now because my code was very high standard, now it actually, what it does, it just looks for the 100%. But now we just changed our image with CSS, and as you can see, it's now 0.98%. And if we put it back into our CSS, if we go back to our CSS code, and we, let's say, want to remove those styling, and we want to keep the original proportions of the images, and now we run the code, now it'll actually be able to find our image, because right now it'll be 100% sure. But things like this could happen if you don't have enough endpoints. This is why I would also encourage you every single time you work with image recognition to have as many images as you can have, so that way those kind of errors would not happen to you. So yeah, let me go back for a sec. So yeah, this was it. This is the image recognition with our 100 lines of code. I hope it was very helpful for you, because sometimes in order to get started with something very complex, you just need to understand it as the very basic things, because as a front-end developer, you don't really need to go into all of those deep parts of the how this actually neural network works, or how this, you basically just need to learn how to use it. And I hope this example was helpful for you. I want to thank you for watching the video all the way up till here, and for staying on the stream with us. And yeah, if you will have any questions about this project, or you want to share something fun, or any other ideas you might have about your own projects, or fun things you can do with it, or if you have, as I said, any questions on how it works, I would encourage you to go to Teachable Machine with Google and create your own model. And actually, when you create your own model, you don't even need to write your own app right away. You can just go to their website and play with your models online. It'll actually allow you to turn on your camera and start showing the objects, and it'll be showing the labels of the objects on their website directly. So when training the model, you can test it on their website directly. So I would encourage you to go to their website and just for fun, create your first model and play with it. And yeah, and if you have any other suggestions for cool projects that I should maybe try with image recognition, and you have some fun ideas, maybe, yeah, share with them or with me too. I would like to work on something cool if you have, guys, any ideas. Or if you want to stay in touch, you can also tag me and we can talk. So that was image recognition, or the intro to image recognition with me. I want to thank you to Data Art, the company where I work, which is a cool company. I would encourage you to take a look on this company if you don't have a current job right now. So yeah, I would encourage you to go to their website and look for cool opportunities there are. And thank you.